Hello everyone, hi, I'm Rashmita Challa. I'm doing Masters in Data Science at UMPC. Today my topic for my project was water quality distribution. So access to clean and safe water drinking is an essential for the well-being of humans. So however, ensuring access to safe water drinking water remains a challenge even in developing countries like Canada. And conventionally, water quality is tested through expensive and time-consuming laboratory analysis that can vary depending on the number of parameters being tested. So my project today was to explore the use of supervised machine learning algorithms and can predict that it can be useful for predicting the potability of water. Next. In this project, I will be addressing these questions. Can we predict water potability? And if we predict water potability, which learning algorithms can yield the most efficient and accurate results? And if so, from those results, can we do hypertuning on those parameters and can yield the best result? After that, is there any relationship between the parameters, like correlation between the parameters? And are there any other parameters which will be affecting the water quality? And how confident are we in our findings? So this is my whole data set. I have taken my data set from Kaggle. My dataset has 9 parameters with 3276 records, and the target variable portability is a binary target variable 1 and 0. First, pH. pH is an important parameter in evaluating acid-basic balance of water. Hardness is mainly caused by calcium magnesium salts. And next, solids. Solids in the water is which has the ability water has the ability to dissolve a wide range of inorganic and organic components. Chloramines are mainly used as a disinfectants in public water systems, which where it is important to be checked. And sulfates. So sulfates are naturally occurring substances that are found in mineral soils and rocks. So conductivity of a water is like ability of a water to allow electric current to pass through it. So but it's a good insulator, and which increases in ion concentration, enhances the electrical conductivity of water. Organic compounds are like sources available from like decaying natural organic matters. And trihalomethanes are chemicals which may be found in water treated with chlorine. And turbidity is ability of water to allow the light to pass through it. So these all parameters helps us to predict the potability of water, where 1 equals to like a potable and 0 equal to non-potable. So in this is my approach to my project. I have done 4 steps: data processing, next modeling training, and next model evaluation, and then conclusion. In data processing, I will be addressing the outliers and cleaning the data and be doing exploratory data analysis. And next, in model training, we have logistic regression, KNN, decision tree, random forest, SVM, XGBoost models. And then after doing ML models, and the models will be done by algorithm comparisons, and then hypertuning, and then cross validation, and then we'll be get into the conclusions. So next, from the visualizations, I have done visualizations, and it can be seen that my target variable was not equally distributed, where the 1 was 39% and 0 was distributed 61%. So from this pair plots, from this distribution graphs, we can see that pH, sulfates, and halomethane were not have more of missing values, and everything was in a Gaussian distribution. And from this visualization, we can see that the correlation heat map, we can see that not all the variables are highly correlate. Everything was independent with each other. And next, from these graphs we can see that the relationship between the predictor variables and pairwise relationship did not yield any obvious linear relationship. As such, we can rule out using simple linear model for the classification. Next, we can see the with the percentages of the missing data, the values pH, sulfate, and trihalomethanes have more missing values, so we will be addressing them too. And when we have checking for the outlier distribution, we can see using this box plots, we can see that the data distribution with the 9 predictor variables and clearly identify outliers they correspond. And when we are dealing with this class imbalance of the data set, and we have done upsampling the minority class to balance the data for the training to prevent bias in the majority classes. So principal component analysis is like it's in this we have tried to decrease the dimensions in the data set. So from this graph we can see that all the variables are independent from each other, and like further confirms our previous observation from the heat map was supporting these documents. And these are the all the ML algorithms have used in the project. So as we have discussed, I have done algorithmic comparison with the first iteration, and then I have done hyper tuning, and then have done second iteration. From the first iteration of the models, the results clearly shows that random forest performs more than 80%. So this, after that, the decision tree and then XG boost, and then where supervised support vector SVM and KNN performs with equal performance. And then next, logistic regression is very least. Next, after hypertuning in the second iteration, we can see that again random forest has performed well with increased in accuracy from the previous, and then SVM and then XGBoost. So further I have done a cross validation using the top three accuracy model, so a random forest, SVM, and XGPUs. So with these here we can see that after evaluating, it is clearly seen that these three random forest, SVM, and XGPUs performs well in the second iteration, so I'll be using them. So using these cross validation results, we can see that SVM has performed with a more accuracy of 87.98, which was very good percentage, which was like close more than 84% in the starting. We have increased 4% approximately at the end of our project. So we will be using SVM for the further analysis of our project to find portability of the water. So from this project we can see that like what recommendations can we see and what interpretations we have done is like we can see that as we discussed, like second iteration and hypertuning parameters, SVM performance was with like first was with 82.25, and then after doing cross validation the performance was increased to 87.98. So, and like water has three parameters to test its portability. They are physical, chemical, and biological. So we have not focused mostly on the biological parameters like coliforms and like physical some chemical metals like heavy metals. So if these were also included in collecting the data set, the accuracy might also be very accurate, and we can also deeply work into neural networks. Next, so for the questions what we addressed in the starting, these were the predictions we had, and yes, using ML it is possible to predict water portability. And support vector machine classifier is like best performance with accuracy of 87.98 accuracy. And after doing the hypertuning, like the accuracy in the model was increased for most of the models. and are there any relationship between the parameters. So the parameters are effective in predicting algorithm had like low correlation. And we also have to consider some other parameters like coliform and heavy metals also be included. And but like our we have confidence with the project, but like there has to be some other parameters like where we which can be unpredictable, like temperature and the surroundings. These may also affect the water, so these can also be depending on place to place and situations. This can also be look have to be looked forward. And so this is my project. Thank you everyone.